Okay, so this is the first lecture of RT525, the Advanced Engineering Materials. 저희 첨단 공학 소재의 첫 번째 수업입니다. So today we'll basically learn what is materials. Well, it should be actually what are materials, right? So we're gonna learn about advanced engineering materials. Right, that we should know what materials first and then move on to advanced materials, and then we're gonna learn what actually is advanced engineering materials are. So this is the very famous drawing or the schematic from the professor Tim Sands from UC Berkeley. So he basically explained how the engineering research has evolved in the last roughly 100 years. So very early 20th century, when people started learning about the quantum mechanics in 1910, which was the era of World War I, then it only had engineering disciplines. People were interested in making structures based on engineering, right? Car wheels, right? Engines, the first industrial revolution, right? So they said if it moves, it's mechanical. If it doesn't move, it's civil, right? So this is like car, train, engine, right? This can be bridge, right? Or water pipes, tunnels, all right? And if you cannot see it, it's electrical, right? You cannot really visualize electricity, right? The circuits are small, so they said, oh, it's electrical, right? And then in 1960, so the Sputnik is the satellite, all right? All right. In 1960, so people actually started to combine each engineering discipline with right science partners, right? So let's say rockets, right? It consists of engineering of, let's say, design of structure, right? And you have to make the system withstand very high temperature of flame, right? And then there is this science, right? Chemistry, right? Chemical reaction to burn the fuel, right? Combustion, right? So all these things start to merge, right? Of course, there was also electrical part, right? Control, timing of the space shuttle, right? And then the development of information technology, cell phones, internet, pagers, and then people started about processing information at the very high speed, and also the emergence of nanotechnology, biotechnology, and information and communication engineering. All these different disciplines of engineerings have merged into one big field. So there is no clear distinction between engineering fields these days, right? So even though we are robotics engineering, I'm teaching you the materials, right? We also have materials department, but they're teaching you the devices, right? Energy department is teaching you a chemistry, right? So everything is merged. And also there is no clear distinction between engineering and science, right? That is exactly what is happening these days. And the materials has followed very similar track, right? So let's look at this figure, right? So this was the evolve of engineering, right? apes, right? People start from the apes and then evolve into the walking human structure. And then you can see this type of tools, right? All right. And this is axe, a hand axe. It's hard, right? Sharp, right? People chose a right material, right? And then people made this long spear, right? People made a structure that is more suitable for hunting or whatever purpose they were doing, right? So they started from the raw material, right? From the raw material into engineered shape, right? And then there is this thing, I forgot what it is in English, but people made a different structures to give more functionality or just give more functions, right? Right. And then they developed this what is called this electrical drill, yeah, right? They started making this electrical drill, right? So they now give a function, electric function, right? Motor to generate power, right? And then people are studying biology, DNA, neuroscience, and they have developed this computer, right? Right. So this is the evolve of engineering, right? We started from the raw material, we changed their shape, we gave them more function, we added electrical function, right? Now we can process a lot of data, a lot of calculations using these computers, right? So everything has evolved and we had to come up with the right material along with the development of the technologies. Okay, so what are materials? All right. So simply put, materials are simply atoms joined together in the solid state. Right? Generally, it's in solid state, right? Of course, there are flexible materials, metaphase materials, emerging materials, but generally we treat this material when the atoms are joined together in solid state, right? It can be just the composition of single atom or the joint or composition of multiple atoms, right? The great diversity of materials reflects the enormous variety, enormous variety in the strength and directionality of atomic bonding, right? Okay. So the materials, different materials consist of different atoms, but they also have different bonding structures. And depending on bonding structures, even though they consist of the same atom, their properties are different, right? So in this case, he mentioned strengths, right? So this is very important mechanical property, right? So the term materials broadly describes everything we use to manufacture everyday objects from cars to bridges, toys to aircraft. So anything that we touch, that we can feel or we use consist of materials, right? And for a specific application, we use a specific material. And to give them a specific function, we design their shape, we design their sizes, right? Right? So we have to pick a right material first, and then we engineer the materials to give them more functions. So everything that we make is based on materials in one form or another, and they underpin just about every modern technological development. So they underpin. So they are underlying. So they are the basis of every modern technology development. So it's everything, right? Every technology, every device, right? Every electronics. We have to choose the right material, or we have to start with the right material to build a device or some product with certain functions. So, okay. So there is this discipline called materials science and engineering that is advancing biomaterials, ceramics, electronic materials, metals, polymers, and emerging functional nanomaterials that affect all engineering areas. Right? So there are so many fields, right? So many applications, and each application, each field requires different materials with different properties. Right? So this field, the material science and engineering, is the field that studies which material we should use. Right? You're actually becoming an engineer who can choose or who can analyze what type of material is required to build a certain system. Okay, so here is the evolution of materials. So it starts from 10,000 BC, 0 year and 2020. So if you look at it, at the very beginning there was polymers and elastomers such as wood, skins, fibers. Right? People before ancient people used wood to start the fire, animal skins for insulation, as a cloth, right? Fibers, right, to make clothes, to write letters, right? And then they used a lot of things from the nature: stone, flint, poetry, right? There's a lot of poetry, right? All right, glass. People start using glass, cement, and so on, right? And then people started to learn how to forge metals, or how to use high temperature to melt metals and make alloys, or to change the shape of metals. So that happens in this area, right? And then in this region, right, the importance of metal increases sharply, right? It increases sharply. The metals start to dominate. And this is the era of World War One and World War Two, right? A lot of missiles, a lot of tanks, a lot of guns, which are majorly consist of metals. So the importance of metals increases, right? So this table basically shows the importance as a function of time. And then starting from here, where the metal reaches its peak, let me change the color. People start to make a new type of metals, right? Light but very strong metals. Also, they start to make polymers, right? Epoxies, high modulus, high temperature polymers, right? The polymers that can withstand or that does not change their shape at high temperature. And also, people start to make composites, right? They make a composite, or they mix different materials to generate a new class of material with outstanding properties. All right, and then the ceramics, glasses, the emergence of piezoelectrics, pyroelectrics, right, thermoelectrics. All those ferroelectrics are majorly ceramics, right? Quartz, right? Aluminum oxide, all those functional materials has dominated, right? So if you actually look at where we are exactly at this line here. Okay, oops, sorry. Okay, I'm using the free version, but I just want to show off my new iPad that, okay, if you look at here, we are exactly here, right? And if we divide into different sections, this is much as metal, this is polymer, this is composite, this is ceramic. And if you just look at it, they're very evenly spaced. Not evenly, but each type of materials are all important. Right? We are living in the era where we have to consider all these four types of materials, right? So that's where we are. That's where we are standing these days. Okay, so what is advanced materials? All right, of course, we know this very famous journal from Wiley. It's really high impact factor journal, right? Advanced materials, right? This has bunch of different branches, right? Advanced healthcare materials, advanced functional materials, advanced energy materials, right? And one of them is advanced engineering materials, right? Right. Okay. So let's look at what are the advanced materials. So advanced materials are the materials that represent advances over the traditional materials that have been used for hundreds or even thousands of years, right? So we've been using a certain material for very long time, and we want to advance their functions, their properties, by changing their shape or adding different materials or by processing them in various environments. So that is what we are doing. And all new materials and modifications to existing materials to obtain superior performance in one or more characteristics that are critical for the application under consideration, right? So simply put, we want outstanding properties. I'm running out of space, right? So let's say copper wire, right? What do we need, right? For electronics, if we want to use them as electrodes, we need very high conductance, right? Lithium-ion batteries, we want extremely high capacity, right? We want them to have really high power density, right? So those are the properties, right? Okay, also, as I said, we are developing many new materials, right? So let's say if there is a material that is early in their product or the technology life cycle. So we are talking about the very emerging materials. Right? In other words, there is significant room for growth in terms of the improvement of the performance characteristics, right, and their product life cycle. So many materials that we are studying in university labs, they are not yet commercialized, but we are studying them. So it is the very beginning stage of their life cycle, but we are studying them. We want to understand their property. We want to understand how they behave under certain conditions, and also we want to use them in a right way. So those materials can be also called advanced materials. Oops, excuse me. So I'm at page 7. All right, there we go. All right. So then, advanced engineering materials, right? We are engineers. But what is the exact definition of engineering, right? Engineering is we are coming up with the new structure or new design of certain material or certain device or a certain component to develop, to improve or enhance their functions, their properties, right? So we can define the engineering materials are used as raw material for any sort of construction or manufacturing in an organized way of engineering application, right? So this is the very important organized way. Okay. So we want to come up with the new design or the new manufacturing in an organized way. So in an organized way, we need a calculation or prediction, how the engineered material will behave under a certain structure, right? Before building a bridge, right? All these architects design bridge, they design the weight acting on different portion of bridge. They also consider wind. They also consider temperature fluctuation from summer to winter, right? So there is a much need for right prediction or during the design stage, right? Okay, so everything we use in our daily life can be tailored to use for specific cases. And this can be done efficiently if we know the property of each material beforehand. Right? Okay. So in common sense, right? When we want to cut something, let's say we want to cut or slice a piece of cake, right? There is a paper, right? And there is metal rod, right? And then there is balloon, let's say balloon. Then we know that, oh, we should use metal rod to cut the cake, right? We have this common sense, right? We have this common sense that if we want to cut something, we need something sharp. We need something hard, right? Okay? And that type of common decision is possible because we know the property of each material. So it is very important. The property is very important when we are talking about material, right? For specific application, we choose a specific material based on their properties, right? When we want to build a plane, we need a hard, durable material that is light, right? When we want to make a hot pot or 주전자, we know that we need to make the 주전자 or the hot pot with the material that has high melting temperature, that can withstand high temperature, right? And also they can conduct heat fairly well, so you can boil the water quickly, right? So there is this common sense or logic that you need to come up when we actually choose a material or when we actually develop a material, right? So if you look at it, there are this common sense, right? So there are these main materials. There is a conductor, right? Conductor. There is an insulator, right? So conductor basically conducts electricity, right? Also, we can say it's heat, right? Insulator, 단열이라고 할 수도 있고요. 뭐 부도체, 부도체, right? Insulator. We have to consider their applications, right? We need to define which material we want to use. We need to come up with the predicted price we want to make a product as cheap as possible. And depending on the application, we want to make it very heavy or we want to make it very light, right? And as I said, there are 4 main material classes, right? And we can say the engineering materials are classified into the above broad groups. All right, so let's see. Let's just give you a very simple example. So I just wanted to show off my drawing skill. So let me choose gray. Nice. Okay. All right. So let's say there is iron. Let's say this is iron. All right. And then what do you want? Then we have a piece of aluminum, right? Or there can be a piece of silicon, right? So these are materials. These three are materials, right? And then people start to mix these materials, right? And then make alloy steel, right? By adding maybe a little bit of aluminum here and there, or a silicon here and there, right? And what does it do? Maybe this can improve their melting temperature, or it can improve their strength, right? Or improve their durability while lowering their weight, right? So depending on our application or what you need, you can mix different, very small content of these metals and add to iron and make it alloy steel, right? So that's very well known, right? So now let's say we have this awesome alloy steel and we want to use it to build a house, right? And then if you are a civil engineer or mechanical engineer, we know the H-beam, right? So all right, let's see. H-beam. All right, yeah, like this. All right. If you go to construction site, you see this type of, oh, it's harder than I thought. Okay. Yeah, something like this. You get what I'm saying, right? So this type of material, right, have different moment of inertia. So basically, it can withstand more strength in a certain direction, right? Or even though it is very light, it can withstand normal stress. Increased resistance to normal stress. Or basically, this is stress in vertical direction. Okay, right? Okay, so using this type of structures, we use this alloy steel and make a nice bridge. All right, we come up with this designs. All right, so this is bridge. All right, design. All right, so this is engineering material. All right, okay. So do you get what I'm trying to say here, right? Materials. All right, and then advanced materials. And then advanced engineering materials. Of course, this is my own definition, right? So some people may not agree, but this is basic. So basically, this is what we're trying to learn, right? We'll start from the materials, then we'll learn about advanced materials or emerging materials. And then learn how they are engineered. to make new type of devices or new type of structures, whatever. Yeah. Okay. All right. I think I'm going a little fast, but I believe you can adjust this video. You can, I believe you can adjust the speed of this video in YouTube or in other players. So I hope it's not a big problem for you. Okay, so, oops, sorry, yeah. All right, so let's look at this. So one of the example is advanced engineering materials, right? So, oops, so it's already shown here, but maybe I'm not too late. Let's say, yeah, let's say, all right, wait, okay. Can anyone name what this is? This one right here? Yes. Yes, you got it. It is graphene. All right, it is one of the most famous two-dimensional material. It's 2D. It's just hexagonal, one atom thick layer of carbon, right? It is ordered structure of two-dimensional carbon. Right, so these are carbon atoms here, right? These are carbon, right? So this is graphene, and they are known to have, they're known to be more higher strength, right? High strength, good ductility, very lightweight, right? So this is the tennis racket. Tennis, yay. Right, and what they did was they added this very small amount of graphene into this frame body of this racket, right? And then they advertise that, oh, this graphene, right, tennis racket gives you more power. It is light, so you consume less energy when you swing this racket, right? Better stability, right? Less vibration. It is more ductile, so it can absorb more shock. Absorb. Shock. Better. Okay? Better racket maneuverable, right? So basically you get better control. Okay. I don't work for this company, so please do not judge me. But this was very cool, right? And this actually draw a lot of attention because, all right, this can maybe embarrass me, but let's see. Let's say, there's a very famous tennis player called Novak Djokovic. So let's type in graphene. All right, and then there is this guy. So this guy right here, right? Trying to say that this racket is so light. This player, Novak Djokovic, can do a lot of things in a split second, right? So everything is stopped, but he's the only one who's moving around. So maybe it's trying to tell you that he has much time because his racket is so light, right? Okay, so that was one good example. All right, let's look at another one, right? So this was one of my favorite movies, right? It's called Classic, right? So if I believe we are about the same age, right? 여러분들 학생분들이랑 저랑 그 나이 차이가 많이 안 나죠, 그죠? So this guy here, right, is 조인성, and she is 손예진, right? So this is the movie classic, right? All right. So during that time, several decades ago, they're wearing clothes. They get wet, right? And this guy is so nice. He's a gentleman. He uses his coat to cover the rain, but you can see this coat is completely soaked, right? So they're all wet, but they're smiling, right? Because they're in love, right? Okay, I'm not sure what I'm trying to say here, but by the development of the new type of fabric, the Gore-Tex, which has this type of very weird looking shape. All right, so if I give you a small preview of one of my later lectures, this is hydrophobic structure. Okay, right? So this type of structure doesn't make your fabric to get wet, right? But at the same time, it has these tiny holes. So there can be air going back and forth. So this type of fabric can exchange heat, right? Can keep you dry, but also resist the raindrops from the outside. So you can see this type of fabric consists of many different layers, right? It's windproof, waterproof, but it is breathable. It's very functional, advanced fabric, right? And if you go to army or 군대, you get your own Gore-Tex jacket, right? Isn't it cool, right? Right, okay. Right. So yeah, so this type of Gore-Tex is another perfect example of advanced engineering materials. All right. Okay. And so there are so many things, like almost every product that we are using these days in our daily lives that uses not only materials, but advanced engineering materials, right? Semiconductors, biomaterials, right? Biocompatible or implantable. 이식할 수 있는, right? Smart materials, right? Materials, those are smart, which has their own functions, right? Or which can make their own decisions, right? So piezo, right, converts electric energy into mechanical energy, right? Magnetic material responds to magnetic field. Optical material responds to light. Photons, right? It can generate electricity, or they are transparent to photons, or they can absorb a specific wavelength, right? So there are many functional materials. Metamaterials, superconductors, topological insulators, right? These may not be familiar or unfamiliar at the moment, but we will learn them as well, right? And then, let me just go green this time. Shape memory alloys, ultra stiff, ultra light materials, right? There are a new class of materials, right? And then also there is my favorite, nanomaterials, 1D, 2D, 3D, right? And then there is this computational science and theory, right? People calculate or simulate and design new materials. They want to predict the properties of new materials. right? Of course, the MD simulation. Now people use AI, deep learning, etc. Right? Of course, there is many more. Maybe let's say, okay, I cannot write here, but let's say there is also 3D, 4D printing, right? Flexible. Right, there are so many types of advanced engineering materials, and we are going to learn all these in this class RT525. All right. So, can you think of any other materials? I believe you can. Right? I'm pretty sure each of you can name at least 10 more advanced engineering materials, right? Right? And all these materials, this field, right? We need to consider materials processing, physics behind their phenomena, synthesis or manufacturing, right? Analysis of their property, come up with the new applications, chemical reaction or chemistry, modeling. So all these are very important, right? So the goal of learning this type of materials is because we want to choose the right materials for a specific applications. Right? And to do that, we need to understand their properties and expect their behaviors. And these are defined by their chemical compositions, atomic bond structures, and scaling. So scaling basically means nano, micro, meso, and blah, 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 right? Even though the same material with the same bond structure, when they become really small or really big, their property changes, right? So throughout this course, we'll study a wide range of emerging materials with high impact on many engineering applications. And we are already behind the schedule, but I'll try to cover as much as possible. And again, this course is introduction to many different fields, many different types of materials, right? So I'm gonna cover a lot of topics, right? Some of the material, the explanation might not be sufficient, or I may gonna skip or short an explanation. So if that happens, please let me know and ask questions. And I believe I have explained how to ask questions in the previous video, right? Okay, so again, engineering materials, we need to understand their structure, properties, performance, processing, and all these is based on characterization and also modeling. Okay, all right, so this is basically what we're gonna learn. So I will send out, by next class, I'll send out a short homework via email. Right, it'll be just probably like one paragraph. Paragraph writing. Right. And you can also pick 3 materials that you want to learn in more detail. Right. So I think, yeah, so that is it for lecture 1. So yeah, thank you, and see you guys in the next lecture. Thank you very much.